So I feel record. I can. All right. So just a recap of the characteristics of the transportation model. We said that usually in this model, you have a product that is transported from several sources to different destinations. Then you have a situation where for each source, there's a fixed supply. And for each destination, there's a fixed demand. So you have to transport the goods from the sources to the destinations, being aware of what? The demand and supply situation. And this means that we must have what? Demand and supply constraints. So we must have constraint for demand and constraint for supply. Where demand is equal to supply, we have what? A balanced model. Where demand and supply are unequal, then we have what? An unbalanced model. So in a balanced model, the constraints are equalities. Whereas in an unbalanced model, the constraints are what? Inequalities. So take note of that. So let's look at an example of a transportation problem. Now, the question is how many tons of wheat to transport from each grain elevator to each mill on a monthly basis in order to minimize the total cost of transportation, in order to minimize what? The total cost of transportation. So as the grain elevator is a source, so that is where the goods are being supplied. And the total, if you sum the total supply, is equal to what? 600 tons. So you move the grains from the grain elevator stations, which are 3 in number, and then you transport them to the mills, which are also 3 in number, but with different demand capacities. And if you sum the demand, it's also equal to what? 600. So supply is exactly equal to what? Demand. So this is what? A balanced what? Model. Okay. Yes. Yeah, so let me check. I think there's a constraint somewhere. Let me check the original listing. So what is 220 is supposed to be 200. Yeah, so correct it. Uh-huh. So it's supposed to be 200. Okay. So that supply and demand all right. So the supply and demand are what? Equal. Okay. Now, what we have here is how much it will cost to transport the goods from the elevator stations to what? The final destinations or to the mills. And what is unique about these problems is that you see that there are row column pairs, and you have to take note of that, because if you don't take note of that, you cannot formulate problems. So this one, you see 1, 1, and A. So we have labeled this one 1, 2, 3, where we know that 1 is what? Kansas. And then A is what? Chicago. So ABC. So take note of that. So this cell, which is 6, will be what? 1A. Okay, that's the position. So you have to take note of that, because if you don't take note of that, you would not be able to understand how the problem is constructed. Okay? So we would have that for each cell. So 12, what position will be 12? To be what? 3C. Okay. So this is what we are talking about. Okay. So we have a situation where we are transporting. Yes, sir. We are transporting the goods from these 3 source points and then we move them to what? The destination points. Chicago, Cincinnati, and then what? St. Louis. Okay. So that's the network of transportation routes that we have to transport the goods. And each route has its cost, and that's what this table is about. Okay. This is how much, $6. It will cost you $6 to transport the grain from what? Kansas to what? Chicago, and so on and so forth.
Where does the transporting start?
You have three destinations, so you don't need to start from any particular place. Okay, there are three different destinations. Look at it from here. Okay, there are three different destinations. Can start from any of the three, depending on how the model is, what the solution is. Okay, so what the solution seeks to tell us how much of this supply in Kansas City should we send to Chicago, and then St. Louis, and then Cincinnati, and how much of Omaha supply should we send to the three, and how much of Des Moines should we send to any of the three? So the solution could be that send everything from what, Kansas to Chicago, and then, but it will not meet the demand, because it's just what, 200, and this is 150. Okay, so it can also be send everything from here to there, but we don't know the solution until we work it out. Okay, so it can be from any of the sources to any of what, the destinations. Now, so here, let's get back and we understand what we are trying to do. We are trying to find out how many tons of wheat do we transport from each grain elevator to each mill to do what? In order to minimize the total cost. So it is this cost we are minimizing. Okay. So the objective function, okay, the objective function will then be a sum of these multiplied by what? The respective what? X's. Okay, a sum of these. So that's why you see that. So how many elements we have there? We have about what? 9 elements. Okay, so that would be what? Minimize. If you remember what I was telling you, from, you see that 1A, you see X1A. 1A, that's this. Okay. 1A. So you have 1B, 1C, and then you come again 2 what? In that order. Okay. And in that order. So that's how you form the objective function. Okay. So you are minimizing the cost. Then we have 2 sets of constraints which are typical of these models. Remember, I talked about what? Supply and what? Demand. So we have to write them out. And we said that these constraints are what? Equality constraints. Because everything has to be what? Supplied. And every destination has to have its demand what? Met. That's what it means. Everything that is at the elevating centers must be what? Shipped to what? The mills. And every mill must receive what? Its shipment. And that's a constraint. So the constraints are constructed in a similar manner, and we have to go through that so that you understand. So look at it from here, how we are going to form the constraints. First, we are saying that we have to what? So first, to be X1A, X1B, X1C, will be equal to the supply there. Supply 150. This is a supply, so it will be equal to 150. We are saying that everything produced here has to be distributed across this. That's what we are talking about. Okay. So you have to look at it from that three-dimensional perspective. Okay. You do that the same thing for this. And then equate that to the respective supply. And then do that for same for the third one. So that's for what? That's the supply constraint. Okay. After that, you have to do the demand constraint. So the demand constraint, that one will be this way. 1A. Yes, then you now come in that order. And then the last one will be what? This, in that order. To get the constraint. So if you don't visualize it, yes, supply and demand. Remember, we are dealing with what? Supply and what? Demand. So the first one, we are looking at supply. What? Everything from what? The source to the destination should be equal. And then what is demanded at what? The destination has to be met fully. That's so the first three are the supply, and then the last three are what? The demand. So what is critical for you is to be aware of the numbering that we provided. That this is 1, 2, 3, and this is what? A, B, C. They form what? The subscripts that are attached to the what? Axis. And I told you that we must know the positions. Yes.
With the demand, the X1 X1, if you have X1 X1A and X1C, and you come and also take X2A, X2B, X2C, and now you give it to the demand function, will that be the same?
No, it won't be the same. We are looking at the so you that will now be the you are turning it. Okay. Just know that the supply is from the grain elevator station, and then the demand is at the what? The mills. Okay, that way it's easy to understand. Then the last constraint is our non-negativity constraint. Now we can now see how to solve that computationally. So let's get exhibit 6.1. Open 6.1. If I
You need to open the site.
yes, that's one.
So, and you will have Excel sheet for
Yes, yes.
that's structure. Then you should
So I said, let me check which one I said they should 6.1. Okay. No. Yes, yes, yes. So that I can now show this the screen.
The jazz. Take me.
All right, so if you open it, this is what you have on your screen. Let's be together. Let's be together. So this is how we set up the system in order to solve the transportation problem. Remember that we said supply in this case is equal to demand. So you have from the sources what is supplied should get to the destination points. So that's why we added a column called grain shipped. And the grain shipped will be a sum of these empty cells in the Kansas City row, Kansas City row. Okay, if you sum them, it should be equal to the grain that what you have shipped. The same for Omaha. The supply, if we sum the empty cells in there, they should be equal to what? The grain shipped. Now, that helps us to get our supply constraint. Okay, the supply constraint will simply mean that the supply should be equal to what? The amount that has been shipped. So the grain shipped should be equal to what? Supply. In other words, everything has been supplied. The same way, if you come down here, we have the demand, which has been provided, and the demand has to be met fully. which means that the sum of the items brought from Kansas, Omaha, and Des Moines should satisfy what is demanded in Chicago, which is 200. So this plus that should is the grain shift. That's this column. Then the same thing with St. Louis. The demand is 100. A sum of these cells should also be 100. So this is a formula cell, this is a formula cell, this is a formula cell. Then the cost is what we are trying to minimize. If you put your cursor on the where the cost is equal to 0, that's 0. Here we are using what we call the sum product. The sum product. You will see that the objective function, we had what? Each of what? The decision variables multiplied by what? The respective cost and summing together. So what we were to do is to pick each element of this times 6, this times 8, this times 10. In that order, this times that, times that, times that, in that order. So we are multiplying the decision variables here times what? The cost. And that's the z is equal to that. Okay, that's our objective function. But in Excel, there's a command which we call the sum product, where once you use the sum product, you would just select this blank space, and then after a column, you come and then also pick this entire space, and that's it. That solves the problem. Pick this entire space, comma, and then this entire space. After prefixing that with what? The sum product. So that makes it easy. Otherwise, you will have to do this times that, and this times that, plus this times that, then plus this times that, plus this times that, plus this prime that. So this is more or less like an easier way of summing up products. Okay, you are multiplying several items and summing. So we call that what? The sum product. Then, once that is done, we can see how the solution looks like. So once again, let's go to data. And then use our solver to just a minute. So when you click on your solver, you will see this window showing up where the solution has been set up, but you can reset it for us to go through again. I've seen that a number of you don't save your time to go through the motions. You just leave it like that. So if you want, you can save it so that we go through how to get the objective, set the objective. This is the function, the cost is the objective cell. So that's what you pick. And then changing variable cells. The empty cells here are the ones that you pick. That's the decision variables. So that comes here. And then for the constraints, there are two. So we have the demand and then supply. So the supply, you select this is equal to that. That's the first one. And then this is equal to that. That's the second one. And then once you choose, the only thing is that once you reset, all these choices will be reset. So if you forget to change it from max to min, you'll be solving it as a maximization problem when it is what? A minimization problem. So if you reset, you have to take note of that. Okay. So if you reset all, you can then okay, so here set objective. So I come and then this which is C10 is my objective. Then changing variable cells. But before then, I must know that it's a minimization problem. So I have to change it to minimize. Then changing variable cells. I come to what? Those blank cells. So from here, so I put, you can see my cursor there. So I can select that entire range. And then I now come to what? Constraints. So here I add. So I say from what? Gene 5 to what? Gene 7. Then I change the sign to equal to be equal to what? F5 to what? F7. Then I add. Okay, then I come to what? That's the demand side. Yes. Okay. So that one, put the cursor, select from this cell. Okay, that's C10. Okay. Then make sure that you change from max to min. So you must select minimize. And then changing variable cells. You select from here to there and that portion. Okay. You place, oh, I see that one too. You put the cursor there. Let me just do it. What? Then you have not yet activated it. That's the problem. Is it your first time? Let somebody help you. You are far behind. Yes. Hello. You are okay. You are okay. Okay.
It's a little problem I have here with our type the whole thing like this for us. How will I also know that I have to arrange it so that
But that's why I'm telling you. You have to learn that.
for this one you have first arranged everything. for us.
Yes. So when I give you a problem, that's how you look at this and arrange it. That's all. Is that not it? That's what examples are about. You will look at it and then enter it in a similar way. This is just a template, not so. Yeah, so you now add the constraints. So the first one, from J5 to J7, then you change the sign to equal to, and then you pick from F5 to F7. Then you add. Then you pick from C9 to E9. C9 to E9. Then you change the sign to equal to, from C8 to E8. Then okay. So we have our demand constraint and then our supply constraint. The method is still simplex. So you can solve. The what? The so yeah, you can that's all. So it's okay. Okay, then you can solve. I've solved mine. Okay. What's the problem? Are you okay? Okay. Victor, are you fine? My friend, today you don't have computer. Wait. Yes, but you have done. If you want. But for now, this is fine. You see that now. Okay, you can click okay, but you do it for now. You don't have a computer. I see. Are you here?
They are moving to go second round.
Hey, second round. Are you here? No. Are you here?
Yes,
Hey, you are late. You are out. Are you with me?
Yes.
Okay. You are there. So. Okay, that's it. Solve. Okay. Why you are not with us?
Yes.
Why?
I just
You are late. Okay. So we shouldn't worry about you. And you haven't solved it. Solve it. Okay. You are late again. Why are you missing?
This changing variable from the previous, like what I've been understanding, we take it from the changing variable.
But they are the decision variables. Labor. So we are saying that this one, you pick it from here, not so. Then change this. This one, I'm saying that pick it from here to here. See here. Something like this. Those empty cells. So that, then you now come to the constraints. The constraints, we are saying that this one so where is the window? I thought the constraint window was open. It didn't open, right? Okay, so then I have to come here. So we are saying that this should be equal to that. Then this should be equal to that. So that's so you can solve. How far?
I came late, sir. That's what.
Kawe ambe yini ya solve the cashier yo. You post solve na cashier.
I want to say this recent so that
Yeah, so this is from here. Then this one we pick from here. The empty cells. This one. This is equal to that. This one. This is equal to this. That's all. Can you see low button? Where am I? Our new class, my year, yo. Can work, man. For what I can't. All right, so let's move. So at this stage, if you want, you can do the answer report the sensitivity report and all that, yes.
That's my fault.
Why is that a problem?
Because I don't know anything about Excel. I can't create any Excel sheet like this.
Why? Why is that so? That would be a big surprise. Now you can't speak for yourself. Yeah.
I think most of my colleagues, I get there.
All right. So usually the fundamental problem is understanding what the structure of the problem is. So if you look at the issue of transportation models, for instance, we are talking about a situation where goods have to be moved from what? Sources to destination. Now, the shipping costs, for instance, that one, you just transpose it directly from the question. There's no need to do it. You just type it from what? The question onto the Excel sheet. But for the equation that will show you the demand and then the supply, remember that we have a decision to make, and we have what we call the decision variables. Okay. And if you go back to the question, you will see that we have several of them, especially even from here, you can tell that all these are X1A, X1B are the decision variables we are looking for. So what we need to do is to create the cell structure such that the supply column is provided. So if let me show you these are the total supplies. Okay. Now, if you look at the question, it means that all the supplies that we will do, the supply combinations we will do to the various meals. This is equal that mass equal to what? The respective supplies. And that's why you have and that's why you have the supply columns here. So it means that everything, so 1A X1A, X1 and then B, X1 and then C should sum up to what? 150 from the constraint. That's this one. Okay. Now, then the same thing for the second one, where we are saying that X2A, now this one, X2B plus X2C should be equal to 175, which is what we have placed here. Okay? And so on and so forth. Now, those are the constraints that we are faced with. And because it is a balanced model, we are saying that when we sum the decision variables, that's these empty cells, and that's what you have here, they must exactly be equal to what? The amount supplied, 150. So that sum is this column, which will be this plus that plus that. That is this. And then if you come to this column, this plus that plus that plus that will be equal to this. This plus that plus that plus that is equal to this. So that what this means is that whatever solution we get for this, and they give us the grain that is shipped, if we subtract it from what? The supply, the answer should be what? Should be 0. Okay. So the main thing is understanding the mechanism underlying the problem. And then once you understand it, you can construct, and it's the same situation that goes with the demand. If we sum this plus that, that is what gives us this cell. Okay, so if you put your cursor there, it will tell you that we are summing this to get that. And because everything that is demanded, that is supply has to be, that is demanded has to be sent to the destination, then it goes by saying that whatever the solution is here, when we subtract it from the demand, it should be what? 0, which means that the demand has been what? Fully met. Yes.
Where will you get the X to multiply with that? Because it's not multiply. Because you are saying that when you do
I don't understand what you are saying.
Subject to
Yes.
X1A plus X1B. Is this not multiplying with the X1A?
It's not my. Were you there from the beginning?
No.
Yeah, so that's why. So the problem is that you come late and you get confused. The 1A is showing you the position of the cell. Okay, so if you take this cell, the position from here is what? 1A. 1A. Okay. So that's how we are looking at it. Okay, so it is not that the one is a number and then the A is also a number, then you are multiplying. Okay. The value in what? Because demand is equal to what? Supply. When you sum the row of a column, it will be equal to what? 600. All right, so once you are here, you can choose, if you want to solve it, you can choose the answer report and then the sensitivity report. Now, so for your purposes in particular, because it may not be possible to bring computers to class for exam, you must understand the reports, how to interpret the reports. Okay, so even if you don't know Excel, like my friend, and many others, but including you, but understand the reports. Okay, you have to understand the report. And then not only the report, because I have to let you understand what the demands are. So for instance, if I give you a problem like this, and I ask you to set up the objective function, you should be able to set it up this way. If I ask you set up the constraints, the supply constraint, you should be able to set it up, because this one you don't need computer. If I ask you to specify the demand constraint, you should be able to specify it. For that one, you don't need computer, you don't need what? Excel what? Knowledge. Okay. So take note of that. Then after you have set it up, I will provide the resource for you. And then now ask you to what? To discuss it. Okay. To be simple. Or I'll do the hard work for you. All right. No, so for those ones we don't take.
It's just a name.
Yeah. But that's the optimal. Yeah. It has no specific significance. So this is the solution to the problem. So it means that we can minimize cost by these combinations. So you see 25 moving from what? Kansas to what? Chicago. Let me see whether this. So that's the advice. So 25, send 25 from what? Kansas to what? Chicago, and then 125 to what? Cincinnati, and then you are cool. Okay, so you don't send anything from Kansas to what? St. Louis. That's the advice. So you come to what? From Omaha, you send everything to what? Cincinnati. Then you come to Des Moines, send 75 to Chicago, 100 to St. Louis, and send nothing to what? Cincinnati. And then that solves the problem. And the cost is minimized at what? $4,525 dollars.
In the interpretation, you can say that you can take only 25 to Kansas, and then to Chicago, nothing. There to the other ones there is
Cincinnati.
That's
No,
no, okay. That's how you take. Is it 100 and no? It's 125. 175.
Yeah.
And then
Yes.
then you count, which will maximize the profit of 420.
It's not profit.
And cost of
Minimize cost.
4,225.
Yes.
And
Yes, for this one.
for
Yeah, very. So you can generate the sensitivity report as well and then discuss it. Why? Okay. So this is a network flow diagram of the solution. Okay, so you should also be able to get a network flow of the solution. So this is just plotting the solution. And that's just what we said, that from Kansas, send what? 25 to Chicago. And then you send what? 125 to what? Cincinnati. And then you see that from Omaha, you are not sending anything to St. Louis. So you are sending what? To Cincinnati in that, everything there. So you can see how the flow is. Okay. So these are the what? The sources. So from the answer report, you can see that the amount that we are sending from Des Moines to St. Louis is 100. From Des Moines to St. Louis is 100. So that's why you are just using to draw this diagram. This you are using the answers here. Remember, these are the decision variables. That's what initially they were empty, not so. Now the solution has been provided. So that's the solution you are mapping. So for instance, if you take 25, that's an arrow running from what? Kansas to what? Chicago. Then you see that from Kansas to St. Louis, there's what? Nothing. So there shouldn't be any arrow, not so. You understand that? Then from Kansas to what? Cincinnati, you have what? 125. So 125 follows that in that order. Of course. Of course. Yeah. Yes. You send all to Cincinnati. So there will be one arrow moving from there. Sure. Yes, more is yes. 175 and then 100. Yes. Nothing. Yes. So that's the arrows that you see here.
But can you have one source? Is it possible to have one source?
Yes, it's possible to have one source. Yes, but it's more interesting when you have several sources.
More or less like have like class.
Yes.
Source.
Yes. Yeah, but that would not be a very interesting problem. No, unless you develop one. You can help us with one. You see? Is what? That's the non-negativity. Yeah. Yeah, so this one doesn't have the solution for that, for the network plot. So you have to do it based on the solution. That's all. Now, so you can solve. Usually the solution is easier with the Excel QM. Okay, so Excel QM, hello, hello. Let's open exhibit 6.7. That one, the solution is usually easier. Yes, that's Excel QM. So usually the Excel QM solution is easier than the Excel solver approach, which many of you are struggling. So for this one, what we can do, remember that this is a transportation problem. So when you are in the Excel QM for Windows interface, this is already open so that I want to show you how to enter the values. Because this one we have already entered it. You can see here that we have demand supply sources and then demand sources. So 3 sources, 3 destinations. So if you want to enter that, you either, if your window is like mine, you can click on the transportation. I will open it later on, so I don't want to, okay? So from here, yes,
The diagram is where
Transportation.
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 Yes, you can access it from the left side, transportation, or you can use module when you go to module. So I can this thing is interfering. If you go to module as well, you can select so once you select transportation, then new, okay, it will bring up the same interface. So it asks the number of sources. How many sources do we have? So there are 3, so we change it to 3. Then the number of destinations. It's already selected from my end as a minimization problem. Okay, where is this thing screen unstable? Okay. So once I click on this, the interface opens up for me. So for this one, we know the demand. So we can type from the demand, the values, the supply, sorry, the supply, the values here, and then the demand, the values here from the question. Then these are the cost elements. You see that we had a table where we had the cost. So these cost elements, this part of the question. So that's what you enter in the various cells in the order that they are appearing. Okay. So the easiest at this moment, just a minute. Is that we already have it in the what's the name? The exhibit 6.1. So I just you can enter it manually, but Can just copy it and paste it there. Okay. The supply is the same thing. We can enter them manually, but we can also just copy and paste. The same with the demand. Okay, so in that case, it's set up. Okay. So from here, you can just solve. That's all. Okay. So this one, you see that Excel QM is telling you that multiple solutions exist. You see this? There are multiple. In other words, you can achieve the same solution. Remember, this is what we got as what the cost minimization. 4525, and it's the same. But if you look carefully, the decision variables are not the same. Why? Because this is an alternative solution. Remember, we said that we have special type of linear programming problem where you can have multiple solutions to one issue. So there can be more than one optimal solution. And this is just showing an example of that. So here, if you want to get the solution, go to the list of solutions. You see solutions, you click on it. You see that it shows you the list of various solutions that have been provided. So we have the transportation result, the marginal cost result, final solution table, iterations, shipment with cost, shipping list. So let me click on shipping list. Among them, what is of interest is the one that shows what? The shipping cost. It tells you that if you are moving the good from one destination to the other, this will be what? The cost. So you have the total cost and what? The unit cost. So the quantity you should ship, and then the cost per shipment. So that one is easy for you to interpret, yes. Where exactly?
In the middle line, we hear what you said.
Oh, what happened? So you go back to the Excel sheet. You would have had to enter these ones manually, but because of the time, you can copy it. You can copy this and go and paste. Yeah, so you have to copy it. Where's your control key? See that? Then you copy the demand and supply as well, the totals. That's from here. Yes, supply copy from here and paste there. Demand copy from here to here and paste it. And that's all. Ah, everyone. SODNs on Agrasa executive. Yeah, Robert Cannon. We were kind of jam.
The power is.
Now, from transportation, we move to transshipment. Transshipment. Now, the transshipment model is an extension of the transportation model. Okay, such that there is an intermediate shipment point or points. There are actually points. There are intermediate shipment points. In other words, instead of just shifting it straight from the elevators to what? The mills. You may be required to shift it from somewhere to the elevators themselves. Okay, so you are shipping the goods from the farm or several farms. So the farm sources are there, you move them from the farm sources, and then you move them to what? The grain elevators, and from the grain elevators, you now move them to what? The destinations. So in that case, you have what we call a transshipment problem. And the items may be transported from one sources through transshipment. In other words, so this diagram illustrates that the S's are the sources, the T's are the transshipments, and then the D or D's could be destinations. You may have several destinations, but this one is just showing you where you have one destination. Okay? Yes. If you want to do what?
Like the example you gave is 3. If you want to make it 4, 5, 6, how will it be?
It is the same. You just increase the number, the solution will be the same. Okay? So if there are 4 sources, the source, you set it at what? 4. But this window shows you how to set it. You increase this to 3, or 4, or 5, or 6. Okay? You can also ship the goods from one source to another. You can also move it from one transshipment point to another. So we can move from T1 to what? T2. Then one destination to another if you have several destinations. Then directly from sources to destinations. So you can have direct from S1 to D1. Then some combination of these. They are all part of the transshipment issue. So let's look at a quick example. So you now have, so we are building on the problem that we have just solved. Okay, so this is an additional information. And the additional information is that the items must come from 2 farms. One at Nebraska and then the other Colorado. And these are the costs of shipping the items from the farms to the transshipments. So in this particular model, unlike the transportation model where Kansas, Omaha, and Des Moines were sources, in this model, they are what? Transshipments. They are transshipments because the sources are now what? Nebraska and what? Colorado. So take note of that. So from the transshipment, we now move the items to what? The destinations, which are Chicago, Cincinnati, and the rest. So you must, what it then means is that in addition to the objective function we had, it will have to be prolonged to satisfy this, because there's a cost of moving the goods from the source to what? The transshipment. So we have to add that cost as well. And then also, we have to also add the transshipment constraint. And the constraint is that everything in the farm has to be what? Transported to what? The transshipment stations. Everything from the farm has to be what? Transported to what? The transshipment stations. So this is the network flow. If you want to look at the entire problem. So these are the farms, Nebraska, Colorado, and then you now move the goods from, say, Nebraska, and then you send some to Kansas, some to Omaha, some to what? Des Moines. And from Des Moines, you now take the goods to what? Chicago, St. Louis, and then what? Cincinnati. In that order. Okay. So these values are the cost. How much it will cost to transport the goods from one what? Station to the what? To the other. Okay. So so what you need to note is this is building on the what? The previous information I gave you on the transportation model. Yes.
From the other diagram, there was a situation where you can take the transport from the source direct to the destination. Now this one.
Yeah, so this model, it doesn't show that. We were telling you that there can be a transshipment problem where you may be required to take it direct. And actually the solution to this problem for some of them may tell us that we should ship direct. So we cannot ignore that. We have not yet solved the problem. Yes. Yes, it can happen. Depending on the production structure we are dealing with. Okay. If it is that when it goes to the station, so some items have to be sent back to the source, then that modeling can also be done in a transshipment transportation model. Okay. Yes. Now, so you see that this way, the objective function has to cut across movement of the goods from the source to the transshipment, and from the transshipment to what? The destination. So the new items have just been added from this table. So this will be what? This will be X1 what? 3. Get that nomenclature right. X1, you see, we have numbered them 1, 2, 3, 4, 5. So if we add the destinations, there are also 3. We'll have what? 6, 7, 8. Okay, take note of that. These are quite complex questions. It needs critical thinking. So this will be what? 1, 4. Okay, X1, 4. Okay, then you can have what? X1, 5 in that order. Okay, so that nomenclature can be seen here. So you can have X1, 3. Okay. Then you have what? X3, X what? 6. So when you look at how the problem is set up, if you come here, you can trace how the mapping is done. That's why I'm just showing that. Because, so remember first we had what? Supply constraints. Then demand constraints. But we must add what we call the transshipment what? Constraint. The transshipment constraint is that everything from the source has to what? Be transported to what? The transshipment points. Okay? Everything from the source has to be what? Transported to what? The transshipment points. And let me show you example from, say, for instance, this, how we get it from the diagram. So here we're saying that everything from what? The source has to what? Get to what? The transshipment. What it means is that what we are taking from, so X1, 3 plus X2, 3 should be equal to X3, 6, X3, 7, X3, what? 8. In other words, whatever we send to what? The transshipment station should be equal to what was available at the sources. At the sources. So if we take out whatever is distributed from here, from whatever was supplied to it from the farms, it should be equal to 0. That's what the first one stands for. If whatever is delivered from here, if we take it out from whatever it received from this ones, it should be equal to what? 0. In other words, everything that is produced at the farm is equal to what is received at what? A particular what? Transshipment station. Yeah. So this is what I was illustrating. So that what you send from the first farm to the first transshipment point, plus what you send from the second farm to that same first transshipment point, should be equal to what you send from that transshipment point to the first destination, that transshipment point to the second destination, and then that transshipment point to what? The third destination. Okay. So that is how you, so and so on and so forth for these other constraints. Then we now add non-negativity constraint that we are shipping positive goods. Okay. So in that case, we can solve it using Exhibit 6.13. So when you open 6.13, this is the interface you have. The empty cells here are the empty cells under relate Atlanta, Durham, Clemson are the decision variables or the changing variable cells. This is what we are looking for. Okay. Then, this being a transshipment, yes, okay, I'm sharing screen, right? But it's not following what I have here. All right.
This is what you want to project.
Yes.
Let's override.
Okay.
This on the project. No,
Yeah.
this one.
Okay, so this is the exhibit. Let me see. 6.11. All right. So here, because this is a transshipment problem, remember that we are moving the goods from the farms to the grain elevator stations, which are 3. So from 2 farms to what? 3 grain elevator stations. And from the 3 grain elevator stations, we now move the goods to what? The destinations. So these are the elevator stations, and these are what? The destinations. So we have a table, first of all, showing us how we move the goods from what? The farms to what? The elevators. And then from the elevators to what? The mills. We have the cost of shipping from farms to elevators and cost of shipping from what? The elevators to what? The mills. Okay. But what is important, worthy of note here is for us to get the constraints. Okay. First, we have the supply constraints from the farm to what? The elevators, which is this. We are saying that the sum of what is here should be equal to the grain shipped, which must be equal to the supply. The sum of what is here also should be equal to the grain shift. So that's here. This is this plus that will give you this. Then, when we now go to the transshipment also, whatever is at that station, we ship to what? The destination, which are the mills. So the same thing, we have our what? Supply constraints, and then the demand constraints. Okay. Then in addition to that, we have the transshipment constraints, which is what we showed here. These 3. So we have supply and then what? Demand. Okay. Then we have what? Transshipment constraints. The transshipment constraints will tell us that everything that we ship from the various farms to the transshipment stations should be equal to what? 0. When we subtract that from what they sent out, remember we said it should be equal to what? 0. Okay. So if you activate your Excel sheet, so let me get it. So that to get the transshipment constraint for, say, Kansas City, what it means is that everything that is shipped there, so that is the 300, should be equal to whatever it also shifts, that from the Kansas to what? The grain mill. So this should be equal to that. That's the constraint. This should be equal to that, and then this should be equal to that. So that's how we got the transshipment constraints. Okay. Then, in terms of the objective function, we use the sum product because we are multiplying these elements by what? The cost elements, and then also these elements by the associated cost elements. So that one we use the sum product. So, and that is what you are seeing in the formula column. Once you put the cursor here, you see the formula for the sum product showing there, and that's what is showing there. So from here, we can solve the model. So if you look at Buddha, I hope those online they are seeing my screen because it's no longer. Mhm. No, I'm not this PowerPoint. So I just want them to be seeing the screen. Yeah. So what the way of selection is similar to what we did with the transportation. The only difference is the transshipment constraint, where you select from that will be C20 up to C22 should be equal to 0. That's the only additional this thing we are doing in addition. So that's this. From this to that we are saying should be equal to what? 0. Okay. So we can solve it. Okay, they are actually. All right. So that provides us a solution of 12,400 with the various decision variables appropriately placed. Okay. The Graduate Students Association, GRASAT, the executives came to us yesterday and we thought that they have to speak with you so that you understand what the association is about, what are your costs and benefits as relating to that association. So the executives are here and they will address you. Yes. So,
President, there's someone.
Allah. So what do we do? You can start. Okay. All right, that's fine. So, so I'm handing over the class to them.
Good morning. Good morning. I am
Central
I'm the organizing secretary